Punnett Square Basics. So a Punnett square tells us the outcome of offspring if you breed two parents together. So for this question, it says the possible outcomes for a chicken that is homozygous dominant for black feathers and a red feathered chicken. So the first thing we have to do is determine what the dominant and recessive traits are. So the dominant trait is black feathers. And the recessive trait is red feathers. So I know this because here it says is homozygous dominant for black. So dominant is black feathers. And then if it's not the dominant trait, it gives you the other trait, which is red. Therefore, the red feathered chicken has to be the recessive trait. So parent 1 is dominant and homozygous. So homozygous, dominant for black feathers. So homo means same. And we represent the dominant trait with a capital letter. So for this one, we're going to say parent 1 is homozygous dominant. For parent 2 is red feathered, and we know that red feathers is recessive. Therefore, parent 2, in order to show the phenotype of red feathers, they need to have two recessive traits. So parent 2 is going to be little b, which is the recessive trait. Okay, so now we're just going to fill in our Punnett square. So one parent's going to go up here. The other parent will go down here. It doesn't matter which parent you put where. So first we're going to start with parent 1, big B, big B. So I'm going to write a big B up at the top of that first column and a big B at the top of the second column. Okay, remember each one of these letters represents an allele. And for genotype, they always come in pairs, right? Because you get one of your alleles from mom and one allele from dad. They come together to make an organism, right? And for parent 2, little b, I'm going to write it here. So this is going to be parent 2. Okay, so the next thing you do is you just pretend these aren't here. You'll take the top letter and you're just going to bring it straight down. Okay, so take this B, we'll bring it here. Okay, and one more, we'll take this B and bring it down. Do the same thing for this letter here. Pretend this doesn't exist. Take this letter, bring it down the column. So we'll take one of these B's, put it there. The next B, and we'll put it there. Now we're going to do the same going across in the rows. So we'll pretend that those aren't there. We're going to take this B and bring it across. So here we have this B will go here. And this B will go here. We'll do the same thing here. We'll take this little B, or pretend this doesn't exist. We'll take this B. Sorry, we'll place it here. I'll take this little B and move it here. Okay, so now we're going to just look at our phenotypes for each one of these chickens. So for this chicken, offspring, this is one offspring, has a big B and a little b for its genotype. So as long as there's a capital letter present, it's going to show the dominant trait. So we know that the dominant trait is black feathers. So We have big B, little b. This one's going to be black. Look at this one. This is a big B, little b. There's a capital letter present. So this offspring will be black. Same thing here, big B, little b. This offspring will be black. And big B, little b again. This offspring will be black. So what is the percent chance that a homozygous dominant for black feathered chicken and a red feathered chicken will have a black feathered baby? Each one of these squares is equal to 25%, right? So we have, this one's 25%. This one will be 25%, 25%. And then this last one will be 25%. So there's a 100% chance that the offspring will have black feathers. What is the percent chance that the offspring will have red feathers? So once again, you just look. All of these are black, so there would be a 0% chance of the offspring having red feathers. Now keep in mind what we write here and here is based on the information that the question gives to you. Okay, so your Punnett squares aren't always going to be situated like this. It's totally dependent upon the parents. Okay, I hope that cleared some things up. Enjoy.